So, sample question paper 3. Any physics question is there? Question number 13. I think the same related to the question previous sample question paper 1 we discussed. Suppose that Rahul uses as a concave mirror and place the object between focus and center of curvature. Concave mirror, we all know that the reflecting surface is going to curve inwards and plot all the terms: pole, focus, center of curvature. So, where the object is located between focus and center of curvature. If it is like this, this one is position number 1, 2, 3, 4, 5 or 6? 4. So, the image will be formed over here. So, the image will be formed over here. So, based upon this, what they are asking, what happens to the image in this situation? What will be the answer? Read the option carefully. Option A, the image is always real, inverted and magnified. So, clearly they said in the question, object is placed between focus and center of curvature, but in question paper 1 they did not say anything about the position, but here they clearly mentioned the position, focus and center of curvature. Based upon that condition you need to say the answer. What will be the answer? A, B, C or D? A. The image is always real, inverted and magnified. It cannot be virtual. Why? Because it will be formed on the screen. Option C and D is not the answer, just forget. Now go to the next question. Imagine Sandeep is examining a concave mirror. He wonders about the relationship between the center of curvature and the focus of the mirror. Which option correctly represents the distance between the center of curvature and focus? Question is here, not in my face. Say the answer. A or B or C or D? So, the question they are saying, Sandeep is having a concave mirror. Clear? I think Sandeep is here only, right? Today is on leave. Yes. He wonders about the relationship between the center of curvature and focus. So, this is going to be pole and this point will be calling it as focus and this point will be calling it as center of curvature. Center of curvature, this distance is going to be radius. Instead of giving the term radius of curvature, they gave it as center of curvature. And instead of giving the focal length, they gave it as focus. So, what is the relation? R is equal to 2 into F. So, this is the condition. Now, say the formula. Say the answer. C. Option C. Think somewhat, then you can easily get the answer. Clear? The answer is going to be option C. Double the focal length. Next. Question number 19. The direction of the magnetic field inside a current carrying solenoid is from south to north. Correct. Assertion is true. Now go to the reason. The strength of the magnetic field produced by the solenoid is directly proportional to the number of turns and the current passing through that. This one also is true. Reason it is magnetic field is directly proportional to the current, as well as magnetic field is directly proportional to the number of turns. That's what they said in the reason also. What is the answer? Either A or B. How many of you saying A? How many of you saying B? B is the correct answer. Reason it is assertion is saying about the direction. Reason is saying about the strength. Both are correct, but this one is not explaining about the assertion. Our answer it is both A and R are true, but R is not the correct explanation of assertion. Yes. What is the significance of principal axis in ray diagram for determining the position and nature of the image formed by convex lens, convex and concave lens? So, what is the significance of the principal axis in the sense what the principal axis is going to play a major role over here if you are using a concave lens and a convex lens. So, if the image is formed above the principal axis, it is going to be positive. If the image is formed below the principal axis, it is going to be negative. The reason it is above the principal axis means it is going to lie along the x-axis, and below the principal axis means it is going to lie along the y-axis and y dash. Y-axis it is going to be positive, and y dash it is going to be negative. That is the reason above the principal axis means we are saying it as positive, and below the principal axis means we are saying it as negative. Next, question number 25. Explain the concept potential difference. Previous question what I discussed. What is meant by potential difference? The amount of work is done to move a charge from one point to another point against electric force, and how it is measured by using the voltmeter. So that means where we need to connect the voltmeter, they are asking where we need to connect the voltmeter. So in a circuit, suppose this is the conductor, and here we need to connect the ammeter. Ammeter always must not be connected in series. They are asking how it is measured using a voltmeter. Where you need to connect the voltmeter? Sorry, parallel across the ends of the conductor. That main word parallel, it is important. Parallel across the ends of the conductor, and here plus, and here it is going to be minus. Yes. So read the question. Rohan is examining an electric circuit. The circuit is made up of 3 resistors connected in series. Totally how many resistors are there? 3. Let us name all the 3 resistors: R1, R2, R3. Condition, they are saying that all the 3 resistors are connected in a form of a series. This is an important word over here. The first resistor has a resistance of 10 ohm. The second resistor is having a resistance of 15 ohm, and third resistor is having a resistance of 20 ohm. Rohan wants to calculate the total resistance of the circuit. So what is the formula to calculate the total resistance? Rs equal to R1 plus R2 plus R3. What is the value of R1? 10 plus 15 plus 20. 10 plus 20, 30, 30 plus 15, 45 ohm. So this is going to be the net resistance, the circuit what is using, and determine the current flowing through it when it is connected to a 12 volt battery and 24 volt battery. So there are 2 conditions are there. First, let us find for the case 1. Resistance we found, what is the value of resistance? 45 ohm. Case 1, they are saying the potential difference as V is equal to 12 volt. What is the Ohm's law formula? V is equal to I into R. I is equal to V by R. I is equal to, what is the value of V? 12 by, what is the value of R? 45. Check whether you can able to simplify the numbers. Yes, by using the 3 table. How many 3s are? 4 3s are. How many 3s are? 15 3s are. Now go along with the normal long division method. 4 divided by 15. Can we divide? No. Add a 0 and keep a decimal place. 2 15s are 30. Remainder 10. Again add a 0. How many 15s are will come? 8. 8 15s are 90. Remainder 10. Again 0. 8 50s are 90. So going down, repeat like this, just stop up to here. So I is equal to 0.288 ampere. R we can write it as I is equal to 0.29 ampere. Like this, calculate for the second case. Case 2. So the resistance is going to be same. R is equal to 45 ohm. What is the value of potential difference? 24 volt. So I value only you are going to find. So what is the formula? I is equal to V by R. So I is equal to, what is the value of V? 24 by 45. How many 3s are? 8 3s are? 15 3s are. So I is equal to 8 by 15. So divide that one. So the 8 divided by 15, that is going to be 0.533. So current I is equal to 0.533 ampere. R we can write it as 0.53 ampere. Clear? Huh? 15 into 8. Hey, someone said 8, right? Wait, we'll do the division again. Do the division. 4 by 15. We can't divide, so we added a 0 and keep a decimal place. 2 15s are 30. Balance 10. Add a 0. Sorry, 90. Remainder 10. So answer it will be 0.266, or you can write it as 0.27. Sorry, no. That one I think it is correct. We did by using the calculator. So okay, no problem. Yes. So direct question. Describe two real life application of parallel combination of resistors. Ah. Okay. Capture this also. So read the question. Imagine you are a presenter at a science fair and you have to set up an exhibit to explain the concept of focal length at your science fair exhibit. How would you describe the concept of focal length and the role determining how convex and concave lens behave when creating image, all within the constraint of brief explanation. So first what we are going to do over here, we are going to prove the focal length. So in order to find the focal length, what lens we are having over here? We are having the convex lens. Clear? So whenever we need to determine the focal length of either it may be a convex or it may be a concave mirror, always we need to choose an object which is located at a infinity position. That's why when the light rays are coming from infinity, after getting refraction, it will converge and then it will fall at one specific point, and that point is called as focus, and the distance between optical center and focus is called as the focal length. So this is what you are going to write about the first statement. And then can you able to determine the focal length of a concave lens? Yes, can you able to determine? No. Reason it is concave will do diverging action. Due to the diverging, the emergent, that refracted rays will appears to meet in the sense it is going to produce a virtual image. Virtual image cannot be obtained on the screen. Clear? Condition for the concave lens. Now what next part what you are going to see over here, behave when using the correct creating image all within the constraints. So what are the difference between the concave and convex lens images when formed over there? So what are the difference will be then? Convex lens will produce real as well as virtual, whereas concave lens will produce only virtual image. Real image can be obtained on the screen, virtual image cannot be obtained on the screen. So the question it is, describe two real life applications of parallel combination of resistors. Provide an example of a situation where the arrangement is advantageous and explain how it works. Any two real life applications? in our day-to-day life where you are seeing? Mention any two real life applications. A parallel combination எங்கெங்கெல்லாம் யூஸ் பண்ணுறோம்? In our home, even in our school campus, all the industries, on what are the places we are seeing over there, all the combination is in a form of a parallel combination. That means we are using in our home, and schools, and then laboratories. Provide an example of a situation where the arrangement is advantage. Sir, what is the advantage of parallel combination? Sorry? Connected in parallel. Connected at one common point, that is advantage. The potential difference will remain same across the ends of each conductor. So because of then, each device will take appropriate amount of current to operate. Second advantage. Third advantage is then, if one device is not working means the other devices will work. Third advantage. Fourth advantage, in parallel combination, the net resistance will be low. Clear? And fourth one overrides. Any other advantages there apart from these four? One, potential difference will remain same, and each device takes appropriate amount of current to operate. If one device is not working means the other devices will work, and net resistance will be low or less. And another one advantage is then, separate switches can be provided. In this 4 point, they are asking any one only. You can just write that one alone. Next, question number 36. Sorry, the question. A student intends to protect the illumination of a candle flame onto a screen located 60 centimeter in front of mirror. They didn't mention what type of mirror it is, but we only need to identify what type of mirror. Real mirror. Super, there is no real mirror. Either it may be plane or concave or convex. Image in the sense we can say it as real image or virtual image. But here we need to find the nature of the mirror. What mirror it is? The mirror it is concave. Real mirror. So from the question we identified one data. The nature of the mirror they provided, it is called as the concave mirror. The student position the flame at a distance of, that position of the flame is nothing but called as the object distance. Object distance u is equal to minus 15 centimeter, and the image is formed on the screen. Condition they set it as mirror. Mirror means either it will be there on the right side or on the left side. left side it will be there. If it is there on the left side means it is going to be negative. What is the image distance? 60 centimeter. Identify the category of the mirror suitable for this purpose. Already we found this one. The category over here, it is called as the concave mirror. Okay. Next, calculate the linear magnification. Linear magnification, magnification, both the meaning are same. What is the formula to calculate magnification of the mirror? M is equal to h dash by h. This one we can also relate along with the object distance and image distance. We can write it as M is equal to minus V by U. So M is equal to minus, what is the value of V? Minus 60 by the value of U, it is minus 15. Minus into minus plus, plus by minus, it is going to be minus. So M is equal to minus 115s are 415s. So M is equal to minus 4. Here what unit I need to write? No unit. Magnification does not have any unit. Next, determine the separation between the object and the corresponding image. Separation in the sense they are asking about the distance. Clear? So let us draw the diagram. So this is going to be the mirror, and this line will be calling it as a principal axis. Object is located at a distance of 15 centimeter. Image is formed at a distance of 60 centimeter. They are asking what is the separation between object and image. How we can find? (60 minus 15). 60 minus 15, that is going to be 45 centimeter. This is going to be the separation between the object and the corresponding image. Next question, accompany your response with a ray diagram to illustrate the process of the image formation in this scenario. How we can draw the ray diagram? Focus. Firstly, we need to identify the focal length. Let's use the mirror formula to calculate the focal length. Just remember about the object distance and image distance. So what is the formula? 1 by F is equal to 1 by V plus 1 by U. So 1 by F is equal to 1 by, what is the value of V? Minus 60 plus 1 by minus 15. So 1 by F is equal to minus 1 by 16 plus by minus 1 by 15. Now do the cross multiplication. 1 by F is equal to minus 15 minus 60 by 60 into 15. Now 1 by F is equal to minus 15 minus 60 minus 75 by 60 into 15. 1 15s are 15. How many 15s are 75? 4. 5. 1 5s are 5. How many 5s are 60? 12. So 1 by F is equal to minus 1 by 12. F is equal to minus 12 centimeter. So this is going to be the focal length. So now we identified all the things. Focal length is going to be 12 centimeter. Object distance is going to be minus 15 centimeter. Image distance is going to be minus 60 centimeter. So based upon this condition, draw the ray diagram. Pole, focus, center of curvature. What is the value of focal length? 12. If focal length is 12 means what will be the radius of curvature? 24. Now look at the condition over here where the object is located. 15. Just say only the magnitude alone, 15. That means it is greater than 12 but lesser than 24. That means where the object is going to be located? Between C and F. So this is going to be A and this is going to be B. So draw the ray diagram. So the point where the two reflected rays are meeting, in that point keep a dot and join this one along with the principal axis and mark the head of the object as A dash and tail of the object image, head of the image as A dash and tail of the image as B dash. So this is how we are going to draw the ray diagram. So read the question. Mark is studying the principle of electricity. He encounters a passage with valuable information about the electric current, electric potential and potential difference. Electric current is a term used to denote the rate at which the charges moves. Ampere is a standard unit of measuring the electric current. The moment of charge always opposes the direction of the electron flows with it. Just read the remaining paragraph. So here what they are asking is Mark is tasked with the defining electric current. What is meant by electric current? Here the important question it is define electric current. Mark whoever it is. Clear? Just write the definition of electric current. What is meant by electric current? Electric current is defined as rate of flow of charges. So after writing the definition, write the formula current equal to charge by time. So after writing this, write in a symbol I is equal to Q by T. After writing this one, they are asking us to, what are they asking? Stating. We should not write the SI unit. What do you need to do? We need to state the SI unit. We all know that the SI unit of electric current is ampere. This ampere we need to state. So then 1 ampere is defined as 1 coulomb of charge is flowing through the conductor in 1 second. Don't make a mistake over here. Here clearly they mention it as state. Explain the relationship between the direction of current flow and the movement of electrons within the current. Within the current or within the circuit? Within the circuit. So we are just going to say about the relationship between the conventional current and electronic current. Both will move in the opposite direction to each other. Clear? So we all know that conventional current will move from higher potential towards the lower potential, whereas the electronic current will move from lower potential towards the higher potential. Lower potential in the sense it is called as negative terminal, and higher potential means it is called as the positive terminal. Next. Mark is tasked to define the electric potential. What is meant by electric potential? The amount of work is done to move a charge from one end to another end against electric force. Describe the concept of potential difference. Sorry, here electric potential in the sense from infinity to one point it will come. Whereas here potential difference in the sense the amount of work is done to move a charge from one point to another point in an electric circuit. Provide the SI unit for both electric potential and potential difference. What is the SI unit of both? Ohm. For both it is going to be volt. Electric potential also it is volt, potential difference also it is volt. Next, Mark is tasked to calculate the potential difference across the resistor which is having a charge of 5 coulomb. So what is the value of Q over here? Q is equal to 5 coulomb. Next, and the flows through it, and the resistor dissipates 25 joule. That means W is equal to 25 joule of energy. So we are going to express the answer in the form of volt. V value are going to find. So what is the formula? V is equal to W by Q. What is the value of W? 25. What is the value of Q? 5. 1 5 is 5 5 is. So V is equal to 5 volt.